welcome back to the course on computer-aided decision systems, where we are trying to learn the big data analytics, and I am discussing the life cycle of the big data analytics system. We have discussed two phases. In the phase 1 we have seen how do we discover the data, how do we understand the business domain. In the phase 2 we had a small introduction on how to prepare the data preparation. Data preparation, we have to interview or we have to meet the sponsor, we have to conduct ETLT analysis, and we also prepare the analytics sandbox. Now comes the phase 3, which is model planning. It is still planning of the model, we are not building the model. In the data preparation, as it was said, we have invested the maximum time to prepare the data, to collect the data, and to put that in the form, to put that in the right transformational form that could be used in the further phases. Phase 3 and 4 we will try to build and we will try to plan the model. But still, before building the model, we have to train the model, we have to see how do we plan or how do we build the actual model, which the model is to be communicated further to operationalize it later. So model planning is the phase that would take the input from phase 2, and here the major things that we do are the clustering, the classification, the finding relationships between the data sets, and we try to also refer the hypotheses which were developed in phase 1. So majorly we try to assess the structure of the data sets. When I say structure of the data sets, whether the data is structured, unstructured, is it available in a formal form, means it is taken by some software or so, or is it available in just a unstructured text which has to be converted into formal text, and what are the opinions of the reviewer or the person who has given the review. So we need to assess the data sets. The structure of the data sets is one of the factors which determines the tools and analytic techniques in the next phase, that is in the model building phase. So it depends whether the team plans to analyze the textual data only or the transactional data. For example, different tools and approaches are required for different kinds of the data sets which are available. So here we majorly cluster, classify, and relate the data. When I say relate, we find the relationships. Now in this phase, the team refers to the hypotheses which are developed in phase 1. These hypotheses helps the team to formulate the analytics which is to be executed in the model building finally. So when the accessing of the data is already taken care of, then we make it certain that the analytical techniques are enabled so that the team meets the business objectives and accept the or reject the hypothesis. We see business objectives are to be met, that is, we plan whether the hypothesis will be accepted or it would be rejected. Right? So this is the second major call that is taken in this phase. We can test the hypothesis such as investment in the innovation research in the company, the increase in the investment made in the innovation by 5% would lead to the 10 products developed in an year. That's all. This is the hypothesis that is tested. We try to accept or reject. This number that is put here, 10 would be developed, 5% investment. I am trying to put very specific numbers here. These numbers could be little varied if required, if we see that in the training data itself, if it is not meeting or it is not hypothesis is not being accepted, so then we try to change the hypothesis statement even to finally build the model. So this here we majorly we are trying to train the data. So these hypotheses could be different for different companies. For the retail companies like Walmart, the hypothesis would be how the sales would increase, how the customers traffic is to be controlled, or the time to the customer spends in the queue is to be reduced to the minimum, or how do we stack the things so that the everything maximum display is there for the items which are there, and how do we deliver them in time, in a timely manner, like people who come to the store itself, or people in the COVID time, it was they had baskets outside the store only, so the order was taken online, and in the baskets itself they used to put the system or the whatever the order was, so the customers used to come and pick it from there. Now itself in Canada, I have observed that people still take the orders from the baskets itself outside the store, so the person from the store comes outside and deliver it there. So what is the delivery time in that, what is the waiting time of the person in the parking lot? So all these could be put as an hypothesis for different companies of different types of objectives that we are trying to meet. Business objective is, how would this value to the customer? How would this increase the customer's loyalty? Loyalty is a very broad term that is also to be brought into a quantitative manner. Maybe loyalty is increased from the rating, from a quality loyalty rating from 1 to 10 person was giving maybe rating 4, now he or she is giving the rating 7 or 8. So how is the loyalty of the person increasing in a way? So these things could be put or could be changed. Another important point in this is, we determine whether the situation warrants a single model or a series of techniques. Single model or series of which means whether the program is just a deterministic model or maybe a small probabilistic model that we are trying to develop, or is it a completely dynamic model where the things will keep on changing as and when the model progresses. So here it becomes a series of techniques. It might be a dynamic programming as well. So dynamic programming in itself becomes little complex. It is only the extreme case when the system is too versatile in a way, when the veracity of the data, that is the variety of the data, and the velocity of the data is heavy. So the data is also unstructured, then only dynamic program could also be taken care in the big data programs. So these are the major concerns which are there in the phase 3. So in addition to these considerations which are listed here, that is 1, 2, 3, it is useful to research and understand how the analysts generally approach a specific kind of problem. So for example, if it is given a kind of a data and resource which are available, then we have to evaluate whether the similar existing approaches which have been applied into the similar processes would work in our system or not. Is our the behavior of the local public similar? Is the environment within my concern or within my company similar? So as the things would change. For example, if some program is successful in US, in India, because the people who are working here might have different perceptions on it, and customers also have different paying capacity or spending capacity, so the programs might be little different. So it could be little different, it could be largely different. So we have to see how do we change that. So this is also determined in the model planning only. So we get the ideas from the analogous problems that the other people have solved in different industry or different verticals, and we try to summarize that. Majorly, if I jot down what kind of sectors and what kind of techniques, you know, in statistics there are certain techniques like multiple regression, multiple linear regression we call it, then logistic regression, we have cluster analysis, we have correlation analysis only where the causality is not taken. There certain techniques are there. So generally, if I put a small table here, I would say sector of the market and generally applied method. So I'll take these sectors here. So let me say if it is consumer goods, like we took in examples of the Walmart or the similar stores there, or second sector I take is retail banking, then maybe retail businesses. Retail businesses is actually the store business, so it is consumer goods which are packaged. Number one is packaged, right? Then wireless telecom. So here in the case of the consumer packaged goods, the program that would be majorly used would be multiple regression only. Multiple regression. When I say a word regression, that in itself means we are only using the linear regression. Polynomial regression is not yet used because the model becomes little complex, or there is a aliases, there is a repetition. So the higher order regression is not there. It is multiple regression. Multi-objective regression could also be there. So objective could be either one, objective could be more than one. If more than one objectives are there, we could even use some heuristics, like we can use genetic algorithm or artificial bee colony, or maybe gray relational analysis. That could still come, but multiple regression is the base technique or method that is used. So other than that, decision tree cannot be missed. Yes, automatic relevance determination, ARD techniques are also there. It is ARD, right? In the case of retail banking, because we are straightforward with the things which were coming, so majorly multiple regression only works. In the retail business, majorly what we work upon is logistic regression. Logistic regression, then automatic relevance distribution, ARD techniques, and decision tree. Logistic regression, how does it differ from the basic regression? In basic regression, the variables can take any value. It could be, it is okay. In the logistic itself, it can be any value, but the predicted value that is taken in the linear regression is generally mean of the target, or it is generally some average or so. In logistic regression, we generally classify yes or no. The email that has come to your office is spam or not spam. The credit card transaction is fraudulent or not fraudulent. So this is logistic regression, where we try to only classify the things. So that is why it is logistic regression, the name called as it. So ARD relevance techniques are the one where we try to employ the Bayesian techniques. That is the Bayesian interpolation or determination. The probability is based upon this kind of the distribution, Bayes distribution only. So decision tree is one that you have learnt in the previous lectures. Dr. Deepu Philip has given you a brief introduction to that. In wireless telecom, there are multiple things that can be taken care of, because wireless telecom do have the data, they have different connections, the people who are connecting, the time for the call, then the rate for which the call is given, different mobile services which are there. So here definitely more sophisticated techniques, like we have neural networks, decision tree. Yes, we have to also classify whether the call is even fraudulent or not, or spam or not spam. So then we have to write here again logistic regression. So when if I have put neural network, that means other algorithms such as artificial bee colony, the genetic algorithm, those could also come here. These are the major classifications that I put, generally which are found more applicable in these kinds of the applications, in these kinds of the sectors in the market. But yes, it is interchangeable. if the problem statement is in such a way that even in the retail business, we are not only talking about the spam or not spam, or fraud or not fraud, we are even talking about what is the percentage increase or what is the number increase. There also the linear regression could also play, or the decision tree or the ARDS techniques could also play. So it depends upon what kind of problem statement, how are you defining the hypothesis. So it can be interchangeable. So the gist of the talk or gist of this table is that there are major techniques which are generally applied, which are approved from the past applications of the past examples, but you can only understand what are the major techniques, what to use where. Once you are aware of the techniques and you are versed or well versed with the different methods, how do we use them, it will itself come. So softwares or the systems are always garbage in, garbage out. So business intelligence analyst has to understand what kind of different techniques are available, what are the major tools which could be used, so those could be applied. I'll talk about the tools and techniques in the forthcoming slides as well. So if I jot down the steps in phase 3, what is to be done in phase 3, that is listed in the previous slide. The steps in phase 3 would be: number 1, data exploration. That is select variable. Which means the objectives of the data exploration is to learn the relationships among the variables so that we understand the problem domain properly. So a commonly used way to conduct this step is involving tools to perform data visualizations. Approaching the data exploration in this way aids the team in previewing the data, assessing the relationship between the variables at high level. So broadly we can put small visualizations here. So that we can see which of the variables are relevant and which are not yet. So in most of the cases, the stakeholders have instincts or hunches about what data science team should consider of analyzing. So often stakeholders have a good grasp of the problem and domain, although they may not be aware of the maybe small nuances of the data or the model needed to accept or reject the hypothesis. So it is the first time. The second case could be the stakeholders may be correct but for the wrong reasons. So the correlations are to be made. We call it the type 1 or type 2 error even. Type 1 error is the alpha error, that is the variables which should be there, which are going to represent the model in the realistic form, are rejected because the analytics or the tests that you have conducted were not correct, or you chose the tests which were not correct. This could be type 1 error. Type 2 error is that the test you have conducted on the sample data set that you have taken, you have selected the variables, but these variables are not representing the final model, or you are not representing the realistic form of the final model. So this alpha or beta error could both come. I write it alpha or beta errors, which is type 1 or type 2. Right, which means sometimes we overdo the things, sometimes we underdo the things, so both are not allowed. So data exploration and selecting variables, both of these errors are to be taken care of. So that is why we draw some correlations, that is in data visualization. Majorly we draw the correlations and try to see what is the correlation, but what is the reason behind the correlation, the causal relationships do not come. For that we have to take further analytics. Now here the team begins to question the incoming assumptions of the initial ideas or initial hypothesis. The assumptions might not be correct, at which might be one of the reasons, or it may be it might need to consider an alternate method, or reduce the number of data inputs, or transform the inputs into the way so that the team best understands it, so best understand the business problem. So maybe the basic business problem is being missed, the team is diverging from the basic business problem. If it is 5% investment in the innovation strategies, the 5% investment might only be made in purchasing the equipment of the innovation, of the 5% investment might only be made in hiring the people only, but actually if it is 5% investment, it has to be distributed proper. The business domain is 10 number increase in the products or the innovative products per year. So for that what is the right input the investment is made in which sector of the company. So that is also one of the points, therefore that data points also might have to be collected. So it depends how do we understand the total business, overall business domain, overall business results. So this is how do we go about. So the key to this approach is to aim for capturing the most essential predictions and variables rather than considering every possible variable, and people may think that might influence the outcome. So it requires a lot of iterations and testing to identify, and the team should plan a range of variables to include the model and then focus on the most important and influential ones. Next comes the model selection. Model selection means here the analytical techniques or short list of the candidate techniques are there, right? We shortlist the techniques here. Shortlist the, then we try to set the rules that if one observes events happening in real world situation or with live data and attempts to construct a model that would emulate this behavior with a set of rules and conditions. So in the case of machine learning or data mining, for example, the rules and conditions are grouped into several general small sets of techniques such as classification, association, rules, clustering, so that we try to solve the given problem. So the data could be a structured data, unstructured data, hybrid approach. We try to identify and document the model assumptions here. The initial models are now taken through some software such as R, SAS or MATLAB. You can move to the next phase, that is the model building. So next step here is selecting the common tools. When I say tools, I am talking about the software packages. This I will talk when I complete all the phases. After we have planned for the model, then comes the phase 4, which is model building. In the model building phase, we develop the data sets for training, testing and production purposes, and we try to develop the analytical model so that the training data would try to train it, that is, it will try to see whether the initial tests are okay to clear. Then holding aside some of the data, that is we call it test data for the testing model, then we try to validate that and we try to go for production. So I will put it here, it is not only training, testing. When I say testing, it includes validation, and then we go for final production. Now here when I'm talking about training and testing, the major data might be 80% 90% of data is taken for the major production. So this is only 10% of the data that is used for training and testing only. So in general, a plan to spend more time preparing and learning the data that was in phase 1 and 2 is imperative, and it crafts a presentation of findings. So phase 3 and 4, moving quickly to them is not helpful. So it becomes more complex unless we have prepared the data and we have planned for the model. So it is critical to ensure that the training and test data sets are sufficiently robust for the model and the analytical techniques. So we need to determine two things here majorly. Number one, whether the model accounts for most of the data. Right. Second question here comes is, so does it have robust predictive power? For instance, if I am picking the regression model only, linear regression only, the output would be a quantitative variable and I need inputs which would also be quantitative, right? I need a metric data, but my data which is available is only in the textual form, which I have not converted into the quantitative form, or data is only available in the qualitative form, yes or no, or so that. So does it accounts for the most of the data? So what is the maximum amount of data that we are available? Do we need to transform that data into the usable form, or should I select something else? Should I select maybe a classification model only? Should I select maybe a chi-square tests, or should I only select a logistic regression, which could be more applied on yes or no models? So robust predictive power. The predictive power means the prediction that has come, would that also represent the final results to be presented or to be communicated to the further phases or not? These two are the major concerns in this phase. So one must take care of the record or any operating assumptions that were made in the previous phases. So this is how it goes. So we create a robust model. What the second question is covering, robust predictive power, it means that do the parameter values which are fitted in the model make realistic sense in the context of the domain, in the business domain that we are selecting. So is the model sufficiently accurate to meet the goal? So does the model avoid intolerable mistakes? That is, how flexible is the model? Right, that means does it allow the intolerable mistakes? So then if we suppose needs to change something in it, are more data or more inputs required? So is the model able to accept more data while running itself? So can we have a parallel running between the model and data ingesting itself? Is a different form of model required to address the business problem? All these questions could also be asked. So this is a quick view of the phase 4. Thank you.